So the greatest integer function is the same thing as the step function. It's just a different way of naming it or calling it. This is your parent function for the step function. You really need to understand it and know it. So let's just say that we make a t-table. And basically what it's saying is if you have 0.5, you will have to round down, so it would be 0. If you have 0.7, you have to round down, and it would be 0. And 0.99, you have to round down, and it still be 0. Once you get to like 1.1, then if you round down, then it would be 1. 1.4 rounds down to 1. 1.9 rounds down to 1. 2.2 rounds down to 2, and so forth. This is why it says that the function that assigns each real number the greatest integer less than or equal to the number. So less than or equal to a number, that's why you have to round down. So if you have decimals, you always are going to round down with a step function. That is why when we have this equation or step function, so anything between 0 and 1 would round down. Notice that at 1, I have an open circle because 0.99 really is really close to 0, but to 1, sorry. It rounds down. But the minute you go to 1, then you would it would be 1. So the minute you hit 1, it becomes 1, and that's why it's a solid 1. Just like all of this right here, you have an open circle until 2, but once it becomes 2, it is 2 up here. So basically what it's saying, it's anything in between 1 and 2, not including 2 right there. You include 2 on the next step. So right here would be between any number between 2 and 3, but not including 3 until you get to the next step. It includes 3. So I need you guys to remember that when we're doing these kinds of problems, what you're basically going to be doing is rounding down. So the answer for this one would be 5. If we round 3.1 down, it will be 3. 0.1 would round down to 0. Negative 0.3 will round down to negative 1. Negative 1.5 would round down to negative 2, and 9.9 would round out to 9. Okay, remember, when we're doing it with the negatives, we're rounding down, so we have to round down to the next number. So again, if you have a number line, this is negative 1, this is negative 2, that negative 0.3 is there, so we have to round down. Just like that negative 1.5, we have to round down. So for this problem, this 3 right here tells me it's going to shift the step function up 3 units. So if we start on the bottom left and we shift this step function up 3 units, that would be 1, 2, 3. That means that now it'll be here to there. And then this one goes up 3 units also. 1, 2, 3. That would be here. And so forth. And the next one would be here. And so forth. Next one there. This would be our shift up 3 units. Since we have a negative 3 inside, the function is going to move everything over 3 spaces to the right. So it's a shift to the right. So that means that if we start at the bottom step function, then if we would go this point right here would be 1, 2, 3. That means it would be right here, or closed, and then open. And the same thing here. It would be 1, 2, 3. And then just basically just keep going from that pattern. And that's our step function. That is shifted 3 units to the right. For this one, this number right here, that it's outside of your function, it's a transformation, so it either stretches or compresses your graphs. So the way, since it's 3, it's going to actually stretch your graph by a factor of 3. So this is going to be a vertical stretch. So for this problem, our first one stays there. That one stays there. But then our next one is going to literally be stretched 3 units up. So these two will no longer be there. It literally will be 1, 2, 3. It'll be stretched right here. So this is where our next one will be, because it's been stretched. And since I can't do anything above it anymore, I'm going to do the one below it. So I know it's going to be 3 down because it was stretched. So it goes here. And that would be an open circle because the one above it was closed. And this would be my closed circle. So this is me stretching this original or my parent graph vertically because of the 3 units. That's what it does. So it's a vertical stretch of 3 units. So this one got moved down basically, and this one up. So it was literally, it got stretched out. These other ones are there, but they're way lower, and these two are there, but up higher. So for this one, we have a negative right here, and what it does, it reflects it across the x-axis. So think of it like a flip across the x-axis. So this function will be flipped over, and it'll be here. This one will be flipped over and will be here. So instead of going up this way, now it's going to be going this way down. So if I flip it, I know my bottom one now is there, and I just keep going down the other way. Everything was flipped over to the other side. This one basically stays there because you can't flip over. If it's on the x-axis, you can't really flip it. It just flips on itself. And this is my equation. So this one became that one. This one was reflected over or flipped over the x-axis, reflected right there. We can reflect this one since it's on the x-axis. Then this one was reflected over the x-axis. So when we have a negative in front of our function, just like in any other function, it's a reflection across the x-axis.